Let's say you're traveling alone in a dangerous jungle. All you've got is your mobile, and all of a sudden your battery got over. You don't have any model to guide the policy. What are you gonna do? Thankfully, you did learn model-free approaches from David Silver, so there is little bit of hope that you will be alive. Model-free means that you don't have this probabilistic crap, or you don't have an idea about the result of an action. It's like traveling blindfold or walking on a Mars, or if you have lost all your memory. If you don't have transition information, the only way you can update the model is by traveling. Now the first way of finding this danger level is based on Monte Carlo evaluation. Whenever you hear the word Monte Carlo anywhere, not just here, always remember it has something to do with expectation or weighted mean. In this case, it is expected reward. If you can see on the screen, there are these 3 episodes which terminate with death. Now you want to learn the danger levels for each state, given that the danger level for death is -1. Now you just find the discounted reward for each visited state for an episode. So for example, if you had visited farm 2 times in the same episode, then my expected reward would be the mean of the rewards obtained in both the visits. Similarly, for multiple episodes, we just sum the discounted reward for each visit and then divide it with the total count. You can also use the moving average to do the same thing, which means on every visit you just update the current expected reward or the state value in a moving average sense. Just a little bit tweaking of state value or the current expected reward. That's what you need to do every time. This approach is great unless you are in an endless journey or if the episode length is very long. In this case, keeping the backup of the state sequence and waiting till it's all over can be a little bit intensive and will not make sense. Here we will follow a simpler approach called TD approach or temporal difference approach. It means instantly updating the state value based on just the next visit, and that too in a moving average sense. It's like V is equal to 1 minus alpha times VE plus alpha times RT plus gamma times V next, where 1 minus alpha times V is the portion of V which was already there, and alpha times RT plus gamma times V next is the portion of the updated estimate of reward. This is because we are approximating the discounted reward by replacing the portion of it by the next state's value function. It assumes that eventually there will be some sort of convergence. If you observe the formula for discounted reward, maybe we can do something about it and have more than one backups for faster convergence. This is where TD Lambda, which has n backups, comes into picture. You can now calculate the discounted reward for 1 backup, 2 backup, 3 backup until n backup, and then what you can do is weighted sum of them. The weights are lambda to the power n for nth backup. So the nth approximation will get the least weightage and the immediate reward will get the highest weightage. David Silver's lecture 4 and 5 on YouTube's are wonderful resource for in-depth understanding of these techniques. I highly recommend you guys to follow up with those videos. Here we are just trying to simplify a small portion of what is discussed in those 10 videos. So if you like our videos, then do subscribe to our channel and press the bell icon to never miss an update from Crazy Muse.